Hi my friends, as I promised, now we'll use the components made in the previous tutorial, and we'll create this assembly, which is a GENEVA drive, an asymmetric GENEVA drive, which is used in transforming the continuous rotation in step rotation. This is the input drive or active drive, and this is the driven part. The particularity here is that it has two arms on this lever which are not at 180 degrees but asymmetric. This is why it is called asymmetric. Well, when we'll have it assembled, we'll see how it works. We start as usual by opening a template, but this time is not an IPT, and for the first time is IAM, which means Inventor Assembly. Good luck. The tool we use is place component. Take a look there and see that there is a shortcut P, the letter P, which accomplish invoking this tool. The action is to offer us possibility of selecting parts to be placed in the future assembly. The recommendation here is to put the static parts, the stable parts, the frame, the support, to have it fixed, not mobile. This is why, instead of choosing parts, different parts, I choose the support. Double click on it and we can place initially in the plane XY, as you can see, but we want it placed in a position of a known placement, not any placement here. This is why I right click here and I choose the option place grounded at origin. This is compulsory to place the first part grounded at origin. I don't need to put another part, so I use escape or OK, but escape is usual. This part cannot be moved from here, and if we look to the browser, we see an origin here, a set of 7 work entities, planes, axis and center point, and as well for the part support another set of 7 elements. this is the assembly triad. This is the triad, and this is the parts triad. Because we placed it, grounded at origin, these are correspondently identical, or identified one over the other. For instance, if I make this visible, the plane XY of the assembly, if I also make visible the other, we see that they are the same. We don't need to see these planes for the moment. I disable visibility, and I make another thing. I look at this part from another angle. If I click here on the home, the view is again as previous. I don't want this. I want to use this to place the part in this position. To make this, I told about, right click here, choose set current view as home. You don't see here because this is the situation with multi monitors, but I tell you what is here. Set current view as home with sub option fit to view. Making this, when the part is any position and I click here, I see it so. This is made to have a proper illumination of the part, and this is why I made the part in this position, special position, when I started to make the support. You remember. And now let's put another part. Let's place another part. Again, place. I choose the lever and I put it here. I don't need another one, so I finish this placement. And now, instead of activating this, I'll press P, the key P, and when I place a part, I press escape, and then I use the space or enter, activate the same place command. Space, Excel 1, 2, escape, space, the other Excel 1, 2, because I need 2 of every such part. Space, the disk here, escape, space, the Malta cross, the roller 1 and 2, escape, and the last is the pin, double click 1 and 2. Okay, I'll move them around here in order to make the known picture. Home for keyboard, and now I keep F3 pressed to get a better situation. I have all the part here, and if you think they are arranged on a table, you are wrong. Look here how they are placed. They are placed in the air, but from the angle we look to, it seems to be on the table. Nothing important about this. Good. Now I have to put them in relation. For instance, I have to put this big. If I choose this part, I click on it, I see here in the browser, I close the other children, I see here that part. If I want to find a part, for instance roller, I click here and I choose find in window, or I tap the key end. Look what happens. That special part come to me. Okay, again. So this is the way you can find a specific part in your great assembly when you work with great assemblies. Good. I want now to place this axle and this hole. To make this, I use the tool constraint. Once again, you see the letter C, which is the shortcut for this command or this tool. Activating the tool, we receive a window, very interesting and very useful. The default selected icons are 1, 2, 3, and the value 0 here at the offset. We use the default selection, and we click on our part. Because this part have an axis, it is very easy to select the axis. I can select the plane, this plane. I can select the point, the center of this circle. But now I select the axis and I go to that hole, and the part comes here. Okay, what happens? It happens that the part is fixed concerning the position axis on axis part in the hole. I can see that degrees of freedom, any part has 6 degrees of freedom, 3 translation and 3 rotation. Let's see. I use view, I click degrees of freedom, and I see that this part, all the other parts have 6 degrees of freedom free, 3 translation and 3 rotation, and this one has only 2 translation and rotation. Rotation is not important because the part is the same all over, but the position along the y-axis is really undefined. I want to fix this part to be so. which means to be with this face on this face. To make this, I go back to assembly and I activate constraint. I choose the other option. This is mate, the same name with this constraint, mate. Mate, you say mate, and here is flush. Flush is the one we need to use, so we use the constraint mate flush. I click on the face and the other face. If you work with the speaker, you will hear bim. I'll open the speaker for you to hear this. Once again, cancel, constraint, flush, click on the support, click on the shot. Now pick is the sound. This means that the part is in position, came in position. Apply, and now only rotation is still not fixed, but it doesn't count, is not important. This is really a rotation, but I don't see it because everything is the same on the surface. Now I'll put the other element here. Now there are 6 degrees of freedom free, not fixed, and now I use other constraint, not mate, not angle, not tangent, but insert. Insert is very useful because you select a circle and you have selected 5 degrees. I have to use the other option here, but I'll show you why. So I select this, I turn the support so, and I select this. The part is on the other side. I don't want to be so. I want it to be in the opposite direction. This is why instead of opposed, I choose aligned. Click and hear the sound. The sound was the first time. Apply. With only one command, I made the same thing like here with 2 commands. I'll make something else now. You see the edges are not visible. I go here to view, I choose visual style, and instead of shaded I choose shaded with edges. Look to the part and look now. We have, oh, I don't want to see inside, with edges but not with hidden edges. These are hidden edges. With edges, visible edges. And now we have some beautiful lines here to see how looks the part. Yes, there is a difference. Okay, Now let's go speedy. I put this here, the lever on this position. Assemble, constrain, insert this here. Apply. The Malta cross insert here. Apply. The disc here comes here. Apply. And now this axle, but I didn't choose the proper circle. I have to choose this circle and not this, because this is at the face. Cancel here to look to the parts and see if they are in a good position. The first thing I can see is, because this has rotation free, I can make rotation. Okay, the same with the cross. Oh, but they are one inside the other. They are not distinct. Yes, this happens because I didn't introduce any other constraint to make this not possible, to be two parts, one inside the other. I apply now Control Z to let it how it was in the constructive position, initially position on the axis. Now I rotate this lever because it has to be so. Now I see both, not so, both holes, and I have to put the axle inside this. Constrain, insert, aligned. I choose this. I go here. I rotate image and I apply this. Pick, and it is in position. The other one is this, and the position is here. Apply. Now the roller, this is, but now is opposed, not aligned. Click on the other icon, click here and here. Once again, one part is inside the other, no problem. This comes here. Apply. Very interesting. And now the last elements, but before I rotate this disc to be somehow aligned with the two holes here. Why? Because I constrain now mate, 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 and choose this axis and this axis to put them together. Okay, now they move together, and I don't need to put these pins here because they are constrained. Only us know that they are necessary. So I apply constraint with the insert a line, this end to this end, apply this end to the other hole. Okay, now we have them very well placed. F6 to see how it looks, or so. I eliminate the presentation of degrees of freedom, and I concentrate on this. You see, we understand that they must be in contact. What kind of contact is here? Tangency. Yes, tangency. I put the constraint tangent between this surface and this surface. Pick. Okay. And now when I move the drive part, I see that the driven part is also moving very correctly, very correctly. Once again, you see, tangent. The problem is that when I go outside, look here, oh, this is not good. Yes, not good, but the constraint is fulfilled. The cylinder is tangent to the extension of this channel. Yes, it comes back. Okay. Oh, I don't want this. Another possibility is to change the tangent constraint, which is placed somewhere. Where? On the browser. What part is this? The Malta cross. Let's see where is the Malta cross. This is the Malta cross. I open this and I see here tangent. If I move the cursor here, I see how is presented that tangency. I click here, I leave it alone, and I see this. Oh, I know what is, and what can I do? I can right click here and I choose edit, and instead of applying a simple tangency, exterior with interior, this tangent is on exterior and this tangent is on interior of the part. I can choose transitional, and I select one part, this is, and the other part, this one. Okay, now is okay, but the roller doesn't get outside, and if gets outside, if I make a very rapid moving here, it goes outside the, it is fully respected what I asked for. This is in contact with the contour of the other part. The contour of the roller is a circle, the contour of the part is a lot of faces. This is why. So this is not good at all. I'll erase it from here, I'll delete it, and now I am free to use both parts freely. And what should I do to create the real movement? This is the part which rotate, and this is the part driven part. To make this, I go to another solution, which is to ask the computer to activate contact solver, which is demand to the computer, to Inventor, to watch if parts from the system are in contact or not. Oh, but I move this and nothing is happened. Yes, because not all the parts with all the parts are in focus, but only the parts I choose. I choose the roller and the cross, Malta cross, but also the other roller. These are the parts in possible contact. So I go here, Malta cross is selected. You see the blue contour. I keep the control key pressed, and I choose roller 1 and roller 2. I selected 3 elements, but they are one near the other, so I can select with shift. You know, this method is generally useful. And I right click here and I choose the option contact set. Now if you see here, they are different against the other. These are in attention of the processor of the computer to be verified by, through the Inventor software, of course, to be in contact. And when I rotate this, as you can see, it works well. More than this, when the other roller comes here, the movement is okay, no problem. The problem will come very soon. Wait for me. Let's put the system in a start position. Start position can be as it was at the beginning, somewhere here. We keep this tool activated and also selected parts as contact set. This. Okay. Let's see this. Now let's see how to make this mechanism to work automatically, not moved by me manually. To do this, we create a new constraint which has impact about the rotation. We choose the drive part, not the driven part, and we choose this face of the lever. You see, I selected the lever here. Go back to assemble, constrain, and choose the constraint angle, the solution 1, the first solution. I select this and this, and now the selected surface is parallel with this green face of the support. Okay, this means that we created a new constraint on the lever. We open the lever and we see here that new constraint angle. We choose this and we apply the option drive. We have this very interesting little window. We put here, say, 360 degrees, because we start from 0 to one rotation, one full rotation, and start the movement. Okay, let's look from the front. We go back, and now be very careful what happens. Stop. It was expected from 360 to go to 0, and the position of this stop is 317. Oh, let's go back. Okay, let's try again. Rewind. Cannot solve here. Okay, what happens? Go back. Mortus. We say mortus. What happens? It happens that we didn't create a good design here, and this is why I have here two sketches to demonstrate what is good and what is wrong. I choose these dimensions. Yes, this is the main part of the design. What we see here? We see 51.5 as the length of an arm of the lever. We see 90 degrees here. We have to engage the roller in the channel at an angle of 90 degrees between this radius and this line. But when we apply this, we find 45 and 13 degrees. This is not good. We have to have here 45 degrees. And why happens this? Because 51.5 is not a good value. And what is the good value? The good value must come from 45 degrees, 90 degrees, and this segment to be equal to this one. Yes, this value is not correct. It has to be equal to this one when here is 45 degrees. And how is the right situation? The right situation is this one, where we have here 73 the hypotenuse multiplied by sinus of 45. The result is here, and the same one is here. Let me show you this. I write here (45) sinus of 45 is this, multiplied by 73, as I said, and the value is just the same. Yes, look here and here and here and also here. Good. Then let's make these modifications to shorten this arm, to lengthen this arm from 51.5 to this value, and to change this one to be the same with this one. How can we do this? We go here, we renounce to all that settings to have no problem with the movement. So we disable contact set, and from inspect we disable activation of contact solver, and we go to this part, double click on it, and let's modify its sketch. We can change different sketches of parts being in the state of assembly and not part. This must be 73 multiplied with sinus of 45. We know now to create expressions. The value is here. If we ask for a precise value, we have this, the same value, you know. If we put an expression, we have here 73 millimeters multiplied by 45 degrees. The default values for 73 and 45 as argument of sinus. Finish sketch. Return. Now we work here. These are not available. They are available, but now we don't look to them, to the other parts, I mean. Return to the assembly. We come to the Malta cross, and we change the diameter of initial part from 90 to 2 times of 73 of multiplied by sinus of 45, and the radius, be sure, is the same like the previous value. Okay, now the problem is that this part, I suppress this this constraint to have the freedom to move all the parts how I want. And you see there is a big interference here when this is in position, and we have to have here a space. This is why we edit also the disk. Double click on the disk, and the first sketch has here this value. Double click on it, and we put here not 51.6 etc etc 52, because we need some room around the Malta cross. Finish sketch. Return from the assembly. Now you see that this is clear, not in contact. Good. Home to see all the picture, and now we come back to our settings. The first one is to unsuppress this, to have this arm in position, in start position. We put this so. I select the three, you know what, 1, 2, 3, and make them together contact set. But now I want to put also this disk in the contact set with the others. Where is the disk? The disk is here. Independently I select it as part of the contact set. Okay, I activate inspect contact solver, and now for the moment I suppress this, and as you can see I can move everything here very smooth. I go back to 0, unsuppress. The movement is very rapid, and the cross didn't come here. Now it is. Good. This is the start position. Let's see all the picture, and now I am sure that we can rotate correctly in a direction, in the opposite direction, without any problem, as you can see. For the moment, I suppose it's enough. Good luck. See you. Don't forget to apply subscribe. Bye bye.